So the real idea we're going to do is to write the equation into a canonical form. First, you write your objective function as a dot product of two vectors. This really is C1, x1, C2, x2, all the way Cn, xn. You always try to minimize. So the previous question, we try to maximize the productivity. How do you minimize? Well, you have two ways to do it. You can minimize the cost, or you can minimize the negative profit, the negative productivity. So my f in the previous example equal 990x1, 900x2. Then you can minimize the f2 equals negative of this. That's a quicker way to minimize. Second, you write your constraint into a list of equations. Then you say, oh, I have an equation. How do I write it into equation? Well, we're going to see we add the so-called slack variable. We're going to see that idea. That's very easy. Once you write into a system like this, you minimize this dot product under the constraint of the equations. All we need is follow the algorithm here. We call it Gauss pivotal method. That's a very straightforward idea. In computer science, we call it a gradient algorithm. So you know our solution must happen on those extreme points. You just start from the origin. That's what 0, 0, 0, the easy way. And just imagine you are standing on the peak of this whatever location in the mountain. And your goal is to find the minimum or say the lowest point along any road you have in front of you. And your strategy is very simple. You start from here, you look, you have 3 directions to go, and then you look at the steepest down slope, and then you go to the next point, or say the next crossroad. And then start from the next crossroad, you have another 2 ways to go, and you again select the steepest road, go down to the next crossroad, and then eventually you are going to end up a position. You look at the other 2 roads along you, each road go upward, and then you know you are in the valley of that mountain. So that valley is your minimum solution. So this again, due to Gauss, and we call it Gauss pivotal method. Remember this idea. We're going to use tableau with the gradient algorithm to solve the linear programming problem manually. And then I also am going to show you how to solve it by MATLAB. But in this previous example, we solved it by graphic method. Let's look at an example how we manually use the Gauss pivotal method to solve this question. A small farm that sells 2 types of crops, A and B. And the profit of crop A sold by $6,000 per ton, and the B $3,000 per ton. And the constraint are the labor hours and the acres of land and the total cash to invest to the small business. So if crop A per ton need to take 2 acres of land, need to work 2 hours on average every week, and they need to invest $3,000, and the B need 3 hours per week, and that's 1 ton, and take 1 acre of land and have to invest $1,000. So the total hours, the total land, and the total money are 42, 18, and 24, respectively. Now the question is very simple. How many tons of crop A and how many tons of crop B this small farm should grow, and then to get the maximum profit annually? So actually, I did one of those kind of problems. Of course, it's 10 times more complicated in some 20 years ago. I helped the small tropical farm to design what kind of crops they should grow and to maximize their profit and also minimize their risks. So we write the standard equation. First, our goal is to maximize the profit, which is 3 times X, because the X sold by 3K per ton, and the 2Y, and the crop B sold by 2K per ton. And the first in equation is the land constraint, have 18 acres of land. Second is the hours of labor per week constraint. And the third is the total capital investment. So we got 3 neat constraints. So to solve this problem, we have 3 steps of preparation to write into the canonical form. And then the fourth step is really complicated Gauss pivot algorithm, as I demonstrated a moment ago. Step 1, very easy, just change the positive into negative, then you can minimize. That's just for the convenience of the algorithm. And the second step, I need to change this 3 in equation to equations. How do I do that? I introduce 3 slack variables, R, S, and T. Those are the positive numbers. You add the positive number equal 18, obviously tell you 2x plus y less than 18. You add the positive equal 42, that means the second is less than 42, and add the t equal 24, that's the same as, say, less or equal than 24. So the bottom line about the 3 slack variables are the R, T, and the S are non-negative. Actually, because this is a real-world application, everything, including the X and the Y, are positive. That's the second step. Then the third step, we write into canonical form with this A really is the same matrix like when we use Gauss-Jordan algorithm to solve equations. Remember that. And the right column, 18, 42, 24, is this B, which is the right-hand constants. And the A really is this part. Let me call that as B. And the real right Ax, x have 4 variables now. Original x, y are the original variable. RST are the 3 slack variables. And then you totally have 5 variables. Now this A is really this. What is the dimension? It's a 3 by 5 matrix. And look at this block. That's like the identity. And each variable, like this one, and this one, and this one, it looks like the base of coordinates. So at this moment, we call them as base variables. And those slack variables in the beginning are the base variable. And so the step 3, we write it down into a standard form. By the way, later on you're going to see when you use MATLAB to solve this problem, all you need is identify this A, this B, and this C. And then when you find the ABC, you're going to use one command to solve the whole problem. So make sure you understand the canonical form must be look like that. Look at the C, get the negative here. It's when you see that T means transpose, means you write it down this way, times x is nothing more than negative 3x minus 2y when you dot this here.